Hey guys, the first video lesson of second semester is over exponential and radicals and also over algebraic expression. Well, exponential and radical is something you have seen in Algebra 2, and algebraic expressions is somewhat factoring and simplifying. So let's start with exponential and radicals. I want you to go on this website because since it's a review, we will go on this website and it's www.mathsfun.com. Once you reach that website, this is what you will get. Once you're on mathsfun.com, I want you to type under the search engine laws of exponents. Once you type there and press enter, these are the choices that you will get. I want you to click on the laws of exponent and go up to the middle of the page, about the middle of the page, where you have the laws of exponent. Now, I will go ahead and explain through this law, and I like the website because it not only it will give us the laws, but it will also give us examples. The first law that you have to know is everything raised to the power of 1 is equal to the same thing. So x raised to the power of 1 is equal to x. For example, 6 to the power of 1 is 6. Now, everything raised to the power of 0 is equal to 1, regardless of what you raise to the power of 0, unless you're talking about 0. Because 0 to the power of 0 is not quite 0. It is still, it may be acceptable as 0, but that's not right. It is undefined. Now, anything raised to the power of -1, as you probably know already, it only means that you will move this to the bottom and it's 1 over the same thing raised to the power of 1. So if instead of x to the -1, I have x to the power of -2, it only means 1 over x to the power of 2. Maybe I should write that down. This is one example that is not labeled. X to the power of negative, let's say 5. This is equal to 1 over x to the power of 5. Going back to our website, if I say x to the power of m times x to the power of n, it's actually just the sum of power. You keep the same base and you add the power. Example, x to the power of 2 times x to the power of 3 is x to the power of 2 plus 3. Now you can replace x by a number such as 2 to the power of 2 times 2 to the power of 3 is actually 2 to the power of 5. The ratio means you divide the power, the exponent. When you have the parenthesis, meaning x to the power of m, that after that being raised to the power of n is x to the power of mn. If I have two bases such as x, y to the power of n, the n will distribute to the x and the y to give me x to the power of n, x to the power of y. You can keep looking at the examples as well. The last one is x to the power of x over y to the power of n. It will distribute just as the product. Now x to the power of -n, this is what I mentioned earlier with x to the power of -5, is 1 over x to the power of n. This whole law of exponent must be on your paper. So if I do not see this table on your paper, at least the law of exponent, I'm not requiring you to write the examples. So make sure you have this on your paper. Besides the law of exponent, we also have radicals. It is equally important. So I want you to have this also on your paper. X to the power of m over n is actually the n root of x to the power of n. Or n root of x, the whole thing raised to the power of n. One more thing that is not here that I would like you to know is actually up here. A fraction exponent like 1 over n means that to take the n root, for example, x to the 1 over n is equal to the n root of x. Once again, make sure you have this table on your paper. In case you have troubles with this law of exponent, I encourage you to read through this website because they do explain every single portion of this law. But all I'm requiring you to have is, once again, this portion of the table. Going back to our notes, we will go ahead, assume on your paper you have the table here. Important. Besides this, I will go ahead and move on to simplify. And when we say simplify, we're talking about simplifying to the point that we will have no negative exponent. So on the simplify, I will say no negative exponent in final answer. Alright, I will start with a very basic example. Let's say we want to simplify the following expression. That will be 3x squared times y raised to the power of 5, and I multiply this by a negative 2 times xy to the power of negative 8. And I will call this one problem number 1. Why not? Alright, to simplify this, I will multiply first numbers with numbers. That will give me negative 6 by doing 3 and negative 2. Now, if I multiply an x squared with an additional x, I will have x to the power of 3. Y to the power of 5 times y to the negative 8. Well, remember, whenever you multiply, you add actually the power. So this is actually y to the negative 3. But this cannot be our final answer because we still have negative exponent. We do not care about this negative in front, but we do care about this negative as an exponent. So the final answer would be negative 6 times x to the power of 3. But because this one had a negative power, I'll put it below and make it positive. And this will be your final answer. Let's do another example. This time, I will have 3x squared, or x to the negative 2, times y to the power of 4, and I'm raising everything to the power of 3. Well, this is equal to, if the power of 3 will be distributed to all of them. 3 raised to the power of 3 is 27. X to the negative 2 to the power of 3 is x to the negative 6. Y to the 4 to the power of 3 is y to the 12. Since this is negative, I will rewrite it as 27 y to the 12 over x to the 6. And that will be my final answer. Example number 3, I will go ahead and write it next to it. Number 3, I will say square root of 18 plus the square root of 50. You know how to simplify this. 18 is actually 9 times 2, and 50 is actually 2 times 25, or 25 times 2. Well, since they're all under the radical, you understand that I can just say square root here, square root here, square root here, and radical here. The plus remain in between. The square root of 9 is 3. Square root of 2, I cannot simplify this. Plus square root of 25 is 5. Square root of 2 remain. Well, I can combine these two to say it is 8 square root of 2. And that will be my final answer. Alright, let's continue with a few more examples. I'll say example number 4 this time. And for example number 4, I will go ahead and have a ratio 2x cubed times 5xy over 20x y squared. Well, I will first try to simplify if I can. Or I can just multiply across. I'll multiply across, although I would prefer to simplify. I just want to show you that you will get the same answer. If we multiply everything here, you will get 10x cubed times x to the power of 4 times y. Nothing will be able to multiply with that y to give something different. And on the bottom, I will remain with 20xy squared. Now, to simplify, I have a single y here and I have two y's here. So this y will go away with the power. I have a single x here and I have a 4 here. This x will go away with this power, turning the power to a 3. The 10 goes away completely with the 20 to give us a 2 on the bottom. So at the end, I will have x cubed over 2y. Alright, now let's do an example number 5. For example number 5, I will just have a number raised to a ratio such as 8 to the power of 5/3. You can rewrite this one by saying, well, it's 8 that is raised to the power of 5, all inside a cubic root. The denominator is the power of the root. The numerator stick to the base. Now at this point, I can also rewrite this as the cubic root of 8 that is raised to the power of 5. I think this expression is easier in this specific case because the cubic root of 8 we know is 2. So I just have 2 raised to the power of 5. And 2 raised to the power of 5 is 32. One last example on simplifying. Let's do number 6. And I will say negative 27 raised to the power of negative 2/3. Well, this negative has no impact on the power has no impact on the negative. So this is equal to, my answer will remain negative because I do not have parentheses here. Now, instead of 27 to the 2/3, I know that this is 27 to the negative 2, all inside a cubic root. But 27 to the negative 2 is actually, I'll keep the cubic root, 1 over 27. Remember, and this is square, of course, 1 over 27 square. I can always put that square on the outside to make it easier on me. Meaning, I could have done also negative the cubic root of 27, keep it as 27, and raise everything to the power of negative 2. That's another way. Now, the cubic root of 27, of course, is 3. With this negative, I will have, therefore, negative 3 to the power of negative 2. What's 3 squared? Obviously 9, but the negative tells me to have, instead of 9, I should have 1 over 9. But this negative remains. Alright, let's move on to something else. At this point, I want to solve, let's do factoring. Once again, this is a review of Algebra 2, or Pre-AP Algebra 2. Let's start with something basic, such as x squared plus 2x minus 15. To factor this, you will look for two numbers that the product gives you 15 and the sum gives you 2. Where the two numbers that the product will give you 15 and the sum will give you 2 are positive 2 is 5 and negative 3. So my answer is x plus 5 and x minus 3. Here's another example. What number was that on above? That was 6. So I will call this one 7. The next one will be 8. For example 8, I will have, let's say, a to the power of 2 minus 16. Well, this is a difference of 2 squared. You should know that a squared minus x squared a squared minus b squared is a plus b, a minus b. Maybe I should write it. A squared minus b squared is equal to a plus b times a minus b. So if I have a squared minus 16, I will know that it is a plus 4 times a minus 4. Example number 9, I will have a slightly different one. Let's say 15a cubed b squared minus 25a to the power 5 b to the power 4. This is an a. And plus 35 a squared b4. First thing you have to do is identify that they all have common factor. The greatest common factor here is 5a to the power of the lowest one being 2. It will be 2. The lowest on b is 2 as well, so it's b squared. And inside the parenthesis, I will have 3. The only thing left here will be an a. Minus 25, that will be 5. Here I will have a cubed b squared plus 35, I will have 7 and b squared. Although you can go further, I will stop here because this can also be a quadratic with a b. Actually, you won't be able to go that far. So this is the best answer, I believe. Alright, that was example number 9. Let's go ahead and change it. And now have something more complicated. Example number 10. Number 10, I will have 3x to the power of, let's do 3 over 2. My exponents are kind of messy. So I will say to the power of 3 over 2 minus 9x to the power of 1 half plus 6x to the power of negative 1 half. Well, they all have that power of 1 half and that x. And they all also multiples of 3. So I can factor definitely a 3 and an x to the power of negative 1 half. X to the power of negative 1 half. Well, if I take an x to the power of negative 1 half and a 3, I'll be left with x to the power of 4 over 2 minus 3x to the power of, this one will be 2 over 2. In other words, I'm saying 1 half times what will give me 3 over 2. Of course, it's 4 over 2. 1 half times what will give me a 1 half. It's actually times 1. So I put 2 over 2. Plus, here will just be a 2. If you simplify this inside a parenthesis, you get 3x to the power of 1. Negative 1 half still on the outside. And this one will be x squared minus 3x plus 2. And this can be factored easily. This is x minus 1 and x minus 2. Two numbers that the product will give you a positive 2 and the sum is negative 3. That will be negative 1 and negative 2. Well, the 3x to the power of negative 1 half remain in front. But since we cannot have negative power, I will go ahead and transform this, and I say this is x minus 1 times x minus 2. The 3 is not being raised to the negative 1 half, so it stays on top. But the x being raised to the negative 1 half goes on the bottom. And I can put 1 half here, or I can put square root. I'll leave it as 1 half. Let's do another one. This time is problem number 11, or problem 11. I will have x plus 4 raised to the power of 2 plus 2 times x plus 4 minus 3. Now, if you look at this, there's the rule that will make it easier. We call it a U substitution. Substitution. The U substitution means you will replace a portion of this, something on this equation by U. So here, I will call all this expression U. Therefore, this expression here will not just be U, but it will be U squared. So if I rewrite this, I will have U squared plus 2U minus 3. And this looks just like a quadratic. Two numbers that the product gives me negative 3, and the sum will give me a 2. That would be 3 and negative 1. So this is U plus 3 and a U minus 1. Since U was not given at the beginning of the equation, I will substitute it back to the equation, and this is actually x plus 4 plus 3 and x plus 4 minus 1, x plus 7 and x plus 3. And this will be, oh, why did I put 4 here? That's one way. That'll be x plus 7 and x plus 3. Now, instead of 4 here, I could have changed it and make it a different value. Let's say instead of 4, I wanted it to be a variable. So instead of 4, let's say I put y. If I put y all over, you don't have to write this. That means here I will say u is equal to x plus y. In this case, at your answer level, you will just leave it as x plus y plus 3, x plus y minus 1, because there's no way to combine. But on the example I just gave you, you were capable of combining the 4 and the 3. All right, let's do 2 more and we stop. But the next one will be number 12. Number 12 says 3 times 2x minus 1 squared plus times 2 times x plus 3 to the power of 1 half plus 2x minus 1 to the power of 3 times 1/2 times x plus 3 to the power of negative 1/2. Yes, this looks lengthy, but let's go ahead and look at it closer. On the first portion, I can multiply this number by this number because they are not being affected by the powers. So the first step is to do 6 times, I still have my 2x minus 1 squared and x plus 3 to the power of 1/2. Plus, I'll move this 1/2 to the front to make it easier. So I will have 1/2 times 2x minus 1 cubed times x plus 3 to the power of negative 1/2. Whenever you look for the common factor, you're always trying to pick the one with the lowest power. So among these two, I know that 2x minus 1 will be a common factor, but it will be raised to the power of 2 because that's the lowest power. The next one will also be x plus 3. That is a common factor, and it will be raised to the power of negative 1/2. Well, I can also take a 1/2 as a common factor. If I do so, what will be left is, from this one, I will now have a 12, because 12 times 1/2 will give me my 6. And I will also have x plus 3, because here is to the negative 1/2. Negative 1/2 plus what will give me 1/2 is plus 1. So this is raised to the power of 1. But of course, raised to the power of 1, as the rule says, we don't have to write this one. Alright, if I continue, I will have a plus here, and everything have been taken here. I will be left with 2x minus 1. I will start by this bracket. If I distribute here, I will have 12x plus 36 plus 2x minus 1. Or this actually will simplify, and it will give me 14x plus 35 in this parenthesis, and this whole thing will transfer back down, meaning 1/2 of, how about we work smart? Instead of transferring everything, I will not touch the one with a negative power. So this parenthesis will be something square, meaning 2x minus 1, and the 1/2 will stay in front, and the one with the negative power will go down, meaning x plus 3 to the power of 1/2. And I can put 1/2 up here, or I can just put a 2 on the bottom, and that will be the final answer. Not too far. Yes, that's exactly the answer. Alright, let's go ahead and finish. By the way, I'm looking at it, I feel like I can take a 7 out. So one more step. So if I take a 7 out, I will have 2x minus 1. And here I will have 2x plus 5. Oh, this is even better. Over 2 times x plus 3 to the power of 1/2. So this is the best answer. This is just minus 1. So I would have lost the point if I left it there. I will give you one problem for you to come prepare in class. This is number 13. And it is x to the power of 1/2 minus 7x to the power of 1/4 plus 10. And here's the hint. U is equal to x to the power of 1/4. Try to complete this. I just want to see if you understand the concept.